In this screencast, we're going to go a little bit deeper into standard deviation. So we know that the standard deviation of a variable tells us how far, on average, the individuals are away from the mean. For example, the mean of IQ scores is 100 and the standard deviation is 15. Some people have IQ scores close to 100, some are further away, above or below. But on average, individual IQ scores are 15 away from that mean of 100. So here's a very useful rule of thumb, sometimes called the empirical rule. About 68% of all individuals are within one standard deviation of the mean, 95% are within two standard deviations, and 99.7% are within three standard deviations. And this isn't strictly true for all data sets, but it's approximately true for many, many data sets. And it's not too far off except for very weird and skewed data sets. So we'll see later on in the course exactly when this rule is precise, but it's just a good way of thinking about standard deviations for any data set. So one standard deviation on either side, 68% of all individuals, rule of thumb. So for example, 95% are within two standard deviations. Well, since the standard deviation for IQ scores is 15, and 2 times 15 equals 30, about 95% of people have IQ scores between 70 and 130. Two standard deviations below, two standard deviations above. And for IQ scores, they follow this rule basically exactly. So this is true. 95% of people have IQ scores in that range. So a very useful way to measure how far individuals are from the mean is in standard deviations. So if someone has an IQ of 115, then they're 15 points above average. But another way of looking at it is that their IQ is one standard deviation above average. And so instead of measuring in units of whatever it is, IQ points, we measure in standard deviations. Z-scores measure that. They tell us how many standard deviations above or below the mean an individual number is. So if we're talking about IQ, the IQ of 150, Z equals 1. It's one standard deviation above the mean. IQ equals 70, then Z equals -2. It's two standard deviations below the mean. If IQ equals 125, then Z equals 1.67. It's 1.67 standard deviations above the mean. So, and Z is called a standardized score. It just measures how far something is from the mean in standard deviations. So the formula for Z is you take the individual called the observed, the number you're interested in, subtract the mean, and divide by standard deviation. So for IQ scores, if someone's IQ is 118, then, well, 118 minus 100 divided by 15 is 1.2. So if someone's IQ is 118, then their Z-score is 1.2. Sometimes we want to go backwards. Suppose a person's Z-score is -0.6, what's their IQ? So we set up an equation. The Z, -0.6, equals some unknown number x minus 100 over 15. And when we solve this equation, we get x equals 91. And if you have trouble with the algebra, let me know and we'll talk about how to do algebra. But the idea is pretty simple. If the Z-score is -0.6, then it's 6/10 of a standard deviation below the mean, and 6/10 of 15 is 9. 9 below the mean is 91. 9 below 100. So sometimes we want to go forward, given an x, find the Z-score. Sometimes we want to go backwards. Given a Z-score, we want to find the x. So that's a brief introduction to Z-scores and how they're sometimes useful for thinking about data in terms of standard deviations.